question 4. Okay, this question is actually very straightforward. It's just the remainder theorem, the factor theorem, and then, of course, good old long division, which nobody really likes. So, let's check it out. So, so use the remainder theorem to find the remainder when fx is divided by 2x plus 3. Now, effectively, the remainder theorem means you just literally find the value of x here, which is, if you solve it, you're going to get exactly minus 3 over 2. If you're not sure how we get that, well, just let 2x plus 3 equals 0, rearrange it, and you get this. Now, all you do is plug this into this equation and see what the remainder is. So let's do it. So we say at the value of minus 3 over 2, the equation therefore becomes, so plug in carefully. So just if you're not sure, always plug in like this. Whip a bracket here so you avoid like little errors. It's bracket squared minus 4. Doing that, I believe you should get an answer of 5. That's it. So therefore you'll say that the remainder of this value is, well, 5. Oops. Okay. Next one, part B, yeah? So use the factor theorem to show that x plus 2 is a factor of fx. So in this case, to show if something is a factor, this implies that there should be no remainder. Okay, in other words, letting x plus 2 equals 0, we can pretty much use the value of x equals minus 2 if you solve it. So B. So again, B is just like A. Plug in the value minus 2 into this equation, same style, and to prove that it's a factor, well, your final solution in your calculus should be 0. No remainder. So no remainder implies that this term can be used to factorize this expression. So it's a factor. So x plus 2 is a factor. Thankfully, these questions usually tell you what to do, so that's cool. Now, C is quite obvious. We need to factorize fx completely. So you could use long division, totally up to you. So I'm going to go ahead and use long division. Okay, so let's do this. So let's see, x plus 2 into that. So this is just going to take a while. So let's quickly write it down. So we go x plus 2 times the entire term, which is 6x cubed plus 13x squared. 6x cubed plus 13x squared. And minus 4. So notice that there's no x term. So we just say plus 0x, just to occupy the space here. Minus 4. Alright, that's it. Now, all we have to do, so to begin this equation, always ask yourself, so how many times does x fit into 6x cubed? Well, this fits in exactly 6x squared times. Another way to just think of it is just divide the terms. And you should get 6x squared. That's another way to look at it. Now, all you do is just multiply this by the factor. So 6x squared times the bracket should give us 6x cubed plus 12x squared. Now, what is the point is, we're trying to basically keep on doing this until we get a final remainder of 0. And then the top half, the quotient bit, would be the part we can factorize. Now, anyway, let's subtract this, yeah? So big bracket, a minus sign. All of this should just give you single x squared. Drop the 0x, so plus 0x, and repeat the process. Now, ask yourself, how many times does x fit into x squared? Well, it fits in exactly x times. Again, do the same idea. X squared divided by x is x. Now multiply x by the factor and you should get x squared plus 2x. God, that's ugly. 2x. Oops. 2x. And now subtract it again. So big bracket minus this. So you should get 0 minus 2, which is minus 2x. And lastly, drop the negative 4 down. So you get minus 2x minus 4. Ask yourself, how many times does x fit into minus 2x? It fits in exactly minus 2 times. Multiply minus 2 with the factor, and voila, you should get identical expression, which is minus 2x minus 4. And again, this will give you no remainder. And that's it, guys, you did it. So now you can effectively say that when x plus 2 is multiplied to the quotient bit, the quadratic bit, you should get the cubic fx value, fx expression. So now, final step is to fully factorize. We need to also factorize the quotient bit here, the quadratic bit. So let's write down the full bits that we're at so far. So we've got x plus 2 times 6x squared plus x minus 2. Now this one's obviously a bit more annoying, so it just comes with trial and error. So I'm just going to go ahead and go on a limb here and just assume it could either be 6x and x when you the two brackets, or 2x and 3x. I'm going to try 2x and 3x first. My tip for these ones is to just use trial and error, honestly, because it's a lot better than thinking too hard about it. Now, where are we? So what we could do here is also what two numbers multiply to make a 2. Well, that's easy. It's just going to be 1 and 2. Now the question is where we're going to put it. So let's just go ahead and put 1 here for a second and 2 there. If we multiply 2x by 2, we're going to get 4x. 1 times 3x is a 3x. So yes, well, fortunately this is correct. We just tested like this. So 4x, so to get plus x, it would be 4x minus 3x. So it would just be, in this case, a positive and a negative. So to get 4x, it would be positive here and negative there. Not bad. And yeah, I guess we're done.